Okay, here's the review for test one. This is the answer key. So number one, what we have to do first is isolate the absolute value, add 5 to both sides. We end up with absolute value of a minus 2 is equal to negative 9. As you know, the absolute value cannot equal a negative number, so we stop right there. We say no solution. Number two, here we have an absolute value inequality. Isolate the absolute value first. That's why I subtracted 8 from both sides. We end up with absolute value of negative 2r is less than 14. Here's the positive case, here's the negative case. Notice that with the negative case, you reverse the inequality symbol. When we divide both sides by negative 2, that is the golden rule of inequalities. You must you must reverse the inequality symbol again. So now we get r is greater than negative 7, r is less than 7. This is a conjunction. It's an and situation. Negative 7 is less than, r is less than 7. The answer is 3. Number 3, we are basically adding two trinomials. Since this is, adding or subtracting. Since this is a subtraction, we must add the opposite. Keep, change, change. We keep all the signs of the first trinomial, change the sign of the operation, and change each term in the other trinomial. So as you can see, I group these together by x squared, x term, and the numbers. So here we need to add or subtract fractions, which requires a common denominator. Multiply 7 numerator to denominator, we get 91/42 x squared. Over here we multiply by 6, we get 162/42x squared. Since we're subtracting these, we end up with negative 71/42 x squared. Here we have multiply by 3, multiply by 2 to find our common denominator of 12. 15 minus 10 is 5, and that's the numerator, 5/12 x. Finally, over here, we change 6 into a fraction by putting a 1 under it. Multiply numerator and denominator by 2. We end up with 5 halves minus 12 halves. The answer is negative 7 halves. So all put together is your polynomial solution. 3 is the answer. Number 4, we have to FOIL. So we multiply the first two terms. Multiplying fractions is very easy. You multiply straight across. 5/6 v squared. The outer terms, 1/2 times 7/4, we get 7/8 v. The inner terms, 9 times 5 is 45, 5 times 3 is 15v. This is reducible down to 3v. Save this. Well, actually, we'll do it now. This is like terms, so we can combine these together. We need to have a common denominator of 8. So we end up with 7v plus 24, which gives us 31v over the denominator of 8. Lastly, we have 9 times 7 is 63, 5 times 4 is 20. Our final answer is here. Number 5, all you're doing is rewriting this expression into exponential form. As you remember, the index becomes the denominator and the power becomes the numerator. So it's 10n in parentheses to the 5/6 power. Here we're going in the opposite direction. We're taking the exponential form and rewriting it into radical form. Since it's the negative power, we're going to reciprocate. 1 over 5n to the 4/3 power. We're going to rewrite this. 3, the denominator becomes the index, and 4, the power becomes the power over here. The numerator here becomes the power here. The answer is 1. Number 4, here we need to simplify. Here we have negative exponents. Any negative exponent with the base only needs to go on the other side of the fraction bar, and therefore making the exponent positive. So we end up with this expression here. Let's go ahead and multiply the 2 times 2 to get 4, x cubed times x squared. Well, that's a total of 6 x's multiplied together. That's x to the 6th power. And our y's are y to the 4th. Finally, we can cancel. We have 3 y's in the numerator and 4 y's in the denominator. So 3 pairs of those will cancel out. We're left with 1 y in the denominator. Number 8. When you have a power of a power, you must distribute powers. 4 times 3 is 12. 4 times 2 is 8. 4 times 4 is 16. All over 2mn. Let's go ahead and multiply m to the 12th times m to the 16th. Well, we add powers when the bases are the same, so we have m to the 28th. As you know, there's an m in the denominator, so they one pair cancel out. In other words, you subtract powers, and 28 minus 1 is 27. N to the 8th minus n to the first is n to the 7th over 2. Number 9, we are simplifying this radical. So here we have prime factorization of 54. That breaks down to 2 times 3 times 3 times 3. The x's and the y's are expanded out. We pair them up because this is square root, and we cancel one of them out, and the other one comes out. We end up with negative 18xy squared, radical 6. Number 2, this is cube root, which means we need to factor, expand, and group them into threes or trios. As you can see, we have these trios, and these x's are trios, and these three y's are a trio. So, as you know, 2 of them cancel and 1 makes it out. That's negative 2 times x times y. Cube root x squared y, because these are leftovers. They never group together with any other trios. Final answer, negative 4x squared y, cube root x squared y. Number 11 and 12, we are adding or subtracting radicals. Simplify first. We have 2 radical 3 times 3 times 3. That's 6 radical 3 minus 2 radical 6 plus 9 radical 3. Combine like radicals. Here we have radical 3 and radical 3. Well, 6 plus 9 is 15 radical 3's minus 2 radical 6. Number 12, cube root. So we're going to factor and collect them into trios. As you can see, one of the 3 makes that. We end up with negative 3 cube root of 2. The invisible negative 1 cube root of 2 minus 4 cube roots of 4. Combining like radicals, these two combine. We have negative 3 and negative 1 cube roots of 2, resulting in negative 4 cube roots of 2 minus 4 cube roots of 4. Number 13, we are distributing, so we're going to multiply 4 radical 3 times 3. We multiply coefficients. That's 12 radical 3 minus 3 times 4 is 12. And we multiply the radical times radical. That's the radicands times the radicands. And 3 times 3 times p. One of the 3's makes it out. 3 times 12 is 36. We end up with answer 2 as our answer for number 13. Number 14, we must FOIL. As you can see, first terms, 2 times 3 is 6. Radical 2 times radical 2 is 2, right? So 2 times 6 is 12. The outer terms, we multiply the coefficient times the number. 2 times 2 is 4 radical 2. 3 times 3 is 9 radical 2. Combining like radicals, 4 plus 9 is 13, because we are only allowed to add coefficients of like radicals, and you keep the radical 2. The last terms, 3 times 2, that's easy, that's 6. So putting all 3 results together, 12 plus 6 is 18, 13 radical 2. The answer is 2. Number 15, we are dividing radicals. And as you know, we must rationalize when there is a radical in the denominator. There are not to be any rats in the basement, so we must rationalize. Multiplying by radical 2 in the numerator and denominator, we end up with radical 6 over radical 2 times 2, which simplifies to radical 6 over 2. Number 16. Here we can simplify first before we even think about rationalizing. So I'm going to take both. I'm going to take 4 over 3, the coefficients, and go ahead and pull it out so it's 4/3. And then I'm going to take both of these radicals and put it under one big tall radical symbol and just have the fraction live inside of it. So we have 5x cubed over 15x squared. I know 5 over 15 reduces down to 1/3. And x cubed in the numerator, x squared in the denominator, gives me x by itself in the numerator. So we have x over 3. I'm going to go ahead and break this up into 2 separate radicals again. 4 radical x over 3 radical 3. And now I can rationalize. So as you can see, multiplying by radical 3, I end up with 4 radical 3x over 3 radical 3 times 3. One of the 3's breaks it out. And 3 times 3 is 9. Final answer, 4 radical 3x over 9. Number 17, when you see an expression is subtracted from another expression, you must reverse the order of the difference. So we are subtracting the 5 halves x squared minus 3/4 x plus 1 minus 3 halves x squared minus 1/4 x minus 4. Keep change, change, ladies and gentlemen. So you must keep all the signs of the first polynomial, change the operation, and change the signs of each term in the second polynomial. So as you can see, I've circled the x squareds, I've boxed the x's, and I've triangulated the numbers, resulting in this nice answer. And these coefficients are reducible and simplified to x squared minus 1/2 x plus 5. Number 18 made a comeback because so many people got this one wrong on the exit slip. So as you can see, when you replace the variables, please use parentheses so you make sure that the negative sign stays with the base. So because these are both negative exponents, we must take the base and the power to the other side of the fraction bar and make the exponent positive. Or in other words, you just flip the sign of the exponent. So they're both negative, now they're both positive. The big mistake that people kept making on the exit slip was they would change the base to positive as well. You do not do that. The base stays the same. Only the exponent becomes positive. So negative 2 to the third power is negative 2 times negative 2 times negative 2, which is negative 8. And 3 squared is 9. Number 19, here we have this expression raised to the power of negative 1/2. Because it's a negative exponent, I'll put the whole thing under a 1 and make the power positive. Now we all know that anything to the 1/2 power is the same thing as a square root. So this one works out nicely because every factor and expanded variable has a partner to group up with. So we have 3 times 3 times x, y, 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 y. Resulting in 1 over 3 times x times y cubed. The answer is 1. Number 20 was a mistake. This should not have made it to the practice test. You will learn about this in Unit 3. Number 21, what is the symbol for no solution? There it is. Symbol for empty set, curly braces. An example of a conjunction is when the solution is between the 2 points, right? What letter in the diagram represents the index? That's B. Radicand is C. And the coefficient is A. Good luck to you on test number 1.